one final example of being able to look at the key properties of these polynomial functions and graphing them. We have this last function, negative 4x cubed plus 4x plus x to the fifth, and we want to just try to go through and get an idea of what this looks like. Now, one thing that we have to be cognizant of is that this is not the leading term, okay? We should probably rewrite the polynomial function in descending order according to the exponents. And so we will write this as x to the fifth minus 4x cubed plus 4x, right? And now what we can do is we can go ahead and start identifying some of the key behaviors of this graph. So first things first is let's determine what the far left and far right behavior is. I think it's pretty obvious that the degree of this graph is going to be 5, which is odd. And then also, we know that the leading coefficient is equal to 1, which is greater than 0. And so what that means is that this is going to fall far left, but it's going to rise far right. Okay, so that's the left and right endpoint behavior, or far left, far right behavior. Okay, so let's hold on to that because we're going to need that later. Secondly, we're going to find the zeros of this. So we're going to set 0 equal to x to the fifth minus 4x cubed, and then plus 4x. Now, we could factor in x from this, and that's going to leave us with x to the fourth minus 4x squared plus 4. This one's a little bit sneakier to factor because we have a trinomial, but it's not a square. It's not in the form of ax squared plus bx plus c, but that doesn't mean it's not factorable. To build an x to the fourth, we can put x squared at both of the ends. To build a 4, we need 2 and 2. And then to get a negative out of that, these both have to be negative. Oh, sorry, right, they both have to be negative for that to be able to get to that positive 4, but also the negative 4 in the middle to add up. And of course, if you don't trust it, you could FOIL it back out. Now, what we could do is we could rewrite this, and that would be x times x squared minus 2 squared. All right, so that's going to be the polynomial factorization. Notice that this has multiplicity of 1. This has multiplicity 2. All right, so we keep that in mind. And so one solution is we said when x is equal to 0, okay, so that's easy enough. But then we have to set x squared minus 2 squared equal to 0. We take the square root of both sides. We get x squared minus 2 equals 0. We add 2, so x squared equals 2. And then we take the square root, and we have to be careful because when we find the square root, there's a positive and negative root to that. Okay, so we get x equals plus or minus the square root of 2. Now, it's probably best if we figure out that the square root of 2 is about 1.41. So we just take the square root of 2, and we get 1.41. All right, but that's helpful for us because we need to graph it. Okay, so it's approximately plus minus 1.41. All right, so, and remember, the multiplicity is 2 there. So what's going to happen is it's going to pass through when x equals 0 at the x-axis. But also what's going to happen is it's going to touch at x equal root 2, x equal negative root 2, and turn around. Okay, because remember, both of those roots had multiplicity of 2. So if I'm graphing this, okay, down here, we have our 3 roots so far. Okay, so we have 0, 0, and it's going to pass through that graph. And then we have negative 1.4, which might be right about here, and then positive 1.4, which might be right about there, and it's going to turn around. Okay, so next thing we're going to do is we're going to find the y-intercept. And similar to some of the other videos that we've seen, it's not really going to help us too much, but we're going to find h at 0, which is going to be equal to 0 to the 5th minus 4 times, or minus 4 times 0 cubed plus 4 times 0, which is equal to 0. So we have 0, 0 is the y-intercept, which is repetitive. Symmetry. Right? So that's where you find h at negative x, and that's going to be negative x to the fifth minus 4 negative x cubed plus 4 times negative x. Okay? And then notice that everything's to an odd power, so it's just going to keep the signs. So we have negative x to the fifth, negative times negative is going to be a positive 4x cubed, and then we get negative 4x. And I want you to notice that every single term changed from the original. So this one went negative, this one went negative, this one went positive when we substituted negative x back in. Two things. That means that we have an odd function, and that also means that we have symmetry about the origin. Okay? Right. So that's important for us to remember as we go through and try to plot these. It's probably best for us to see what happens in between these zeros. And remember, we said it's going to fall to the far left. It's going to rise to the far right. So let's see what happens at x equal negative 1 and x equal positive 1. Okay. And let's just determine the values of the function there. So let's find h at negative 1, which is going to be negative 1 to the fifth, and then minus 4 times negative 1 cubed, and then we had plus 4 times negative 1. And if we compute this, negative 1 plus 4 minus 4, which is negative 1. So we know we have the point negative 1, negative 1. So let's plot that down here. All right, so right about here. And since there's symmetry, I'm almost guaranteed, in fact, I know if it's reflective about the origin, it's going to be there, right? But let's just verify by plotting the point or finding it h at 1, which is going to be 1 to the fifth minus 4 times 1 cubed plus 4 times 1, which is going to turn out to be 1 minus 4 plus 4, which is 1. So we do have the point 1, 1, right? So if we go through and sketch the graph of this, okay, so remember, it falls to the left. And remember, it touches right here, but it doesn't go through the axis, okay? So it's going to go down. It's going to come back up around. And now here, it's going to go up, okay? And then it's probably going to do this, touch, and then go back up there. Okay, so I'm guessing that's what's going to happen with this because again, this is a point and this is a point, so it has to come back down. And remember, it only touches at these points. So remember, this is the square root of 2 and 0. This is the point negative root 2 comma 0. Okay, and then we have the point here, negative 1, negative 1. And we have the point here, 1, 1. Okay, of course, the origin. Now, let's see what happens if we were to sketch this graph by using a graphing device. So we have x to the fifth, and then we have minus 4x cubed, and then we have minus 4x, right? And I'm going to scroll out a little bit, and it looks like, unless I graph this incorrectly, so let me go back to the original function. All right. So I wonder if I plotted these points incorrectly. No, this looks good. So it just looks like when we graph this function, oh, this is at the point 1. Okay, so if I zoom in a little bit, right here, it's crossing through these. It's passing through. Oh, this is a plus. There we go. All right. So I was confused for a moment, but I made the sign error there. Apologies. But clearly we look at this, and if we plot some of the points, okay, so remember we have square root of 2, comma 0. Okay, so I'm just going to plot some of these points just to see what happens with the graph. All right, we're going to label it. And then we have negative root 2, comma 0. All right, so notice those are the intercepts. We had the points negative 1, comma 1, or negative 1, excuse me. And then we also had the 0.11. And then finally, we also had the origin. All right. And I know it's a little bit dense right here. All right. And so it looks like that the turning points are a little bit past those 1s, okay, or the negative 1. But that's okay, because remember, all we're trying to do is we're just trying to get a basic sense of what the graph looks like, okay? Um, so hopefully that helps you to see that, yeah, we can sketch the graphs of these polynomial functions and at least get a rough idea. If we wanted to, we get a few more points between here to be able to get a more accurate graph. Okay, but certainly this gives us a basic idea. And so that's all for polynomial functions. And so we're going to lead up to the point to where we're able to find a little bit higher order sort of polynomial functions and work with those, especially when the zeros and also some of the other sorts of components aren't necessarily easy to factor. Okay, so we're going to take a look at those. What happens when we get these sorts of functions that aren't as easy to factor? But before that, we have to take a look at polynomial division and a few outcomes of that, which is going to be in the next section.